Good afternoon, my YouTube viewers. It's Crystal here. I'm just here to give you another code review. I haven't made a code review in a few days because I've been studying, and obviously studying is hard work, and I've been studying JAX, and so that's what I'm going to give you the code review on, is JAX. So, I wrote the program in Google Colab, and I'm going to be using the Titanic dataset. And the reason why I'm using the Titanic dataset is because I couldn't get the code to work on the Titanic datasets on a few algorithms that I was studying. And so the Titanic dataset is a bit of a difficult dataset to use. And so I want to do it using a difficult dataset, because if it will work on the Titanic dataset, then hopefully it will work on easier datasets as well. And so I use Google Colab, which is a free online Jupyter notebook hosted by Google. JAX is also a library created by Google. So we're just going to be using Google the whole code review, really. So the first thing that we want to do is we want to import our libraries. So we're going to import pandas as PD because I had to use the Titanic data set, and I didn't want to use it on Kaggle. I wanted to use it on Google. We're going to import JAX, which is a library that is written very closely to the NumPy API, but it can't do everything that NumPy can do, but NumPy can't do everything that JAX can do. So JAX is for research purposes, and it's set to replace TensorFlow. We're going to import jax.numpy as JMP, and so that is the part of JAX that resembles the NumPy API. We're going to import sklearn train test split, and we're going to import matplotlib.pyplot as PLT. So those are the libraries that we're going to be using for this code review. We're going to load our data set. So data equals pd.read.csv, and then you've got the web address for the data set. And you can see it. I printed off the data set. Obviously, it looks to me like a European made this data set because it's got commas instead of full stops. So what we're going to do is we're going to convert the commas to the full stops. So now in the data set, instead of having a comma and a number, you're going to have a full stop. Now we're going to impute the null values for age. And so if they're an adult, it's going to be the median age, and if they're a child, it's going to be 9. And so I figured that was between the middle, between 0 and 18. So now we've got our age and our ages imputed. Now we're going to impute the value for fair. So if it's what we're going to do is we're going to replace the null values with the most commonly used value for fair. And so we're going to use the mode. We're going to convert objects files to floats. So if it's an object, it's going to be a float. So that's going to be changed on the age and the fair. So now it's not an object, it's a float. We're going to round the fair and the age and convert them to integers. We're going to convert the age and the sex to a float after we have imputed it. So we've replaced we replaced the male and female with 0 and 1, and we replaced adult and child with 1 and 0. And so now for the sex and the age of the child or the person, it's going to be either a 0 or a 1. We're going to drop the ID. You don't need the ID, and the reason why is because Pandas automatically indexes each row of data. This is some Matplotlib code that I put in that I really like. This is, you're just plotting the ones and the zeros, and I really like it. It looks really good, and I just put it in there to add a bit of flair to my code review, really. Now we're going to define our X and our Y variables. So your Y variable is the survived column, and your X variable is your data set where the survived column is dropped, and you're going to print your X shape and your Y shape. And you could also use pop on the Y variable, which is what I had originally done, but I was having some problems getting the code to work in another algorithm, and so you're willing to try anything. So I did the old standby drop, which drops the survived column. I checked the info, and you can see that now all of the columns of data are integers. And then I standardized the data, the X variable. And so basically, because I'm using JAX, I couldn't get it to standardize the way I wanted it to. So I said mean equals JNP dot mean X values, axis equals 0, STV equals JNP dot STD, X dot values, axis equals 0s. And then we standardized it, X equals X minus mean over STD and X. And that's the way that I did it, because JAX is harder to work with than NumPy in some respects. So that's the way I standardized the data. So now what I did was I converted the X and the Y variables to JNP arrays. And then I used sklearn train test split to split the data set up into training and testing data sets. So now what I did was I just set the seed, and I'm not sure that we actually used a seed in this, but I made it anyway. Key equals jax.random.prng key 42. And now we've got our KNN classifier. So I thought that this particular algorithm is shorter than a lot of algorithms, which was quite nice. I've worked with some really long algorithms, and I couldn't get them to work. Even on NumPy, I couldn't get them to work. And I thought, well, if I can't get it to work on NumPy, I'm not going to work on it. Okay, so with the KNN classifier, that's your class. We've got the init function, which initializes K. You've got your fixed function, which self.xtrain equals X and self.ytrain equals Y. You got your predict function, which is ypred equals self._predict X for X and X. Return JNP array ypred. And then you got your _predict function, which does the most work. So the first thing it does is it computes the distances between X and all examples in the training set. It sorts the distance and returns the indexes of the first K neighbors. It extracts the labels of the K nearest neighbor training samples, and it returns the most common class label. And then so that's what you got, the most common class label. And then we've got the accuracy, which is a good algorithm. depth accuracy, it accepts y true, y pred. Accuracy equals JNP dot sum. Y true equals y pred over len y true. And then it returns your accuracy. So now we're going to use the code to actually get the classifier to work. KNN equals KNN classifier. K equals 3. So that means we're going to be looking for 3 neighbors. KNN dot fit X train Y train. So we're going to convert X train Y train. I'm going to initialize that. Then Y pred equals KNN dot predict X test. So we're going to use X test to make the prediction. And then so we print predictions, Y pred, and so you've got a bunch of 1s and 0s, which is what we want. And then we're going to print the accuracy, which is 77.86%, which isn't too bad. That's about normal for the Titanic dataset. So now what we're going to do is we're just going to compare it with sklearn's, K nearest neighbors, and you had an accuracy of 78%. So sklearn performed better than our made from scratch version, but it just shows you that it does work. And that's what we want to know, is it does work. And we did it in JAX. So what we had done was we had translated NumPy into JAX. But it does take a little bit of work because JAX can't do everything NumPy can do, and NumPy can't do everything that JAX can do. So it's not a straight translation. So it's not as easy as it looks, which is why I wanted to make a code review. But I really am pleased that I got to translate it from NumPy to JAX, and it worked. And that's why I'm doing this code review. So I'm going to go ahead and conclude the code review because I have talked about everything I want to talk about in this code review. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. Thank you so much again for watching my video. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And I will be communicating with you in the next video.